The best drones for surveying in 2024. Have you ever thought about how surveyors get such accurate measures and maps of huge areas of land? Do you think there are tools that could change the way we measure land, making it faster, more accurate, and cheaper? We'll look at the best drones for surveying in 2024 and how these cutting-edge technologies are changing the surveying business in this video. Which of these drones might be best for your next project? How do they work? Watch out to find out. The fast-paced world of surveying requires efficiency and accuracy. Due to technological advances, drone surveying has revolutionized land surveying. It opens up many applications, from topographic and photogrammetry surveys to construction site and environmental surveys, and is faster and cheaper than older methods. As we prepare for 2024, we must stay current on the best surveying drones. DJI Phantom 4 RTK, DJI Mavic 3 Enterprise, DJI Matrix 350 RTK, and Autel Evo VI Pro RTK V3 are top candidates according to expert reviews. These drones capture and analyze data like no other thanks to their RGB, LiDAR, multispectral, hyperspectral, and thermal sensors. To master drone surveying, you must grasp the process, which entails careful planning, flight planning, and data processing and analysis. You may elevate your surveying by using drone technology and remaining current. DJI Phantom 4 RTK. Top survey drones include the DJI Phantom 4 RTK, a precise RTK, real-time kinematic navigation system enables accurate positioning and efficient data collection. The DJI Phantom 4 RTK is ideal for surveying due to its powerful flight performance and superior imagery. DJI Mavic 3 Enterprise. Another popular survey drone is the DJI Mavic 3 Enterprise, which performs well and is versatile. Its high-resolution camera, obstacle avoidance sensors, and intelligent flight modes are useful. The DJI Mavic 3 Enterprise is perfect for surveying in diverse contexts because to its small size and ease of use. DJI Matrix 350 RTK. Professional survey drones like the DJI Matrix 350 RTK collect accurate data. It has a dual RTK system for centimeter-level location. Users can choose the best sensors for surveying from the DJI Matrix 350 RTK's several payload options. Autel Evo VI Pro RTK V3, advanced RTK technology, and a professional camera make the Autel Evo VI Pro RTK V3 a powerful survey drone. Its RTK module provides precise location, and its high-resolution camera collects extensive data. The Autel Evo VI Pro RTK V3 is ideal for tough surveying jobs due to its lengthy flight time and durable build. Drone surveys produce precise topography maps. Surveyors can create elevation models, contour lines, and other topographic features using aerial photos and photogrammetry. This data is essential for urban planning, engineering, and land development. Photogrammetric surveys. Photogrammetry surveys build point clouds, DMs, and 3D models from overlapping aerial photographs. This method allows precise item and surface measurements. Photogrammetry surveys are common in construction, mining, and archaeology. Construction site surveys. The construction sector is embracing drone surveys. They help surveyors track development, evaluate site conditions, and provide accurate as-built models. Construction companies can eliminate costly errors and enhance project management by taking aerial photos or surveys. Agricultural surveys. Drone surveys have transformed agriculture by giving crop health, irrigation, and yield data. Drones can detect agricultural stress, nutrient deficits, and pests using multispectral or thermal sensors. This data helps farmers optimize operations and make data-driven decisions. Conservation and environmental surveys. Drones aid environmental monitoring and conservation. They can survey and map environmentally sensitive areas like forests, wetlands, and coral reefs. Wildlife behavior and migration patterns can be studied using thermal-sensored drones. Drones may also monitor pollutants and identify environmental issues. Sensor types for drone surveying. RGB sensors. Color sensors, or RGB sensors, catch red, green, and blue light. Drones may take high-resolution color photographs for visual mapping, feature extraction, and photogrammetry surveys with these sensors. RGB sensors are found in most survey drones because they give vital data. The LiDAR sensors. LiDAR sensors use laser pulses to detect distances and build precise 3D terrain maps. Even in difficult conditions, they can penetrate vegetation and collect elevation data. LiDAR sensors are useful for volumetric calculations, DM generation, and obstacle detection. A multispectral image. Multispectral imaging uses visible, near-infrared, and other wavelengths to capture images. This method reveals crop stress, vegetation indices, and plant health. Drones with multispectral sensors can assist farmers monitor crop conditions, regulate irrigation, and spot disease and nutrient deficits. Ultraspectral cameras. Hyperspectral cameras capture images in several tiny, contiguous electromagnetic bands. These sensors can detect small reflectance fluctuations, allowing precise plant, mineral, and other material characterization. Drone hyperspectral imaging is utilized in agriculture, geology, and environmental monitoring. Thermal sensors. Thermal sensors, also called infrared or thermal cameras, measure heat from objects. They can take thermal photographs of temperature, heat signatures, and energy loss. Drone thermal sensors are used for construction inspections, search and rescue, and animal monitoring. Plan and prepare. To collect data efficiently and effectively, drone surveys must be planned and prepared. This includes project needs and goals assessment, determine survey goals and data requirements, identify the survey area and any noteworthy features, assessing the site, check the survey location for risks, airspace constraints, and environmental issues, find barriers that could alter flying route or data collecting, verifying permits, learn local drone laws, gather survey permissions and authorizations, choose the right drone and sensors, select the right drone and sensor for the survey, consider flight time, cargo, data resolution, and sensor compatibility, equipment preparation, make that the drone, sensors, and other gear operate, calibrate and test before the survey, check the survey day weather forecast, avoid surveys in windy, rainy, or hot weather. Flight planning. Flight planning determines survey mission route, altitude, and image overlap. This includes flight area definition. Use mapping software to determine the survey area. This helps determine flying path and coverage. Calculating flight altitude. Determine flying altitude based on data resolution, safety, and restrictions. For accurate data processing, ensure image overlap at altitude. Calculating picture overlap. Choose the image overlap based on data accuracy and survey type. Photogrammetry surveys should overlap more than visual checks. Flight path planning. Create an optimized flying path using flight planning software to cover the survey region. Route planning should include aviation limitations and no-fly zones. Checklist for pre-flight. Make a pre-flight safety checklist with all relevant checks. This will guarantee no important tasks are missed before launching the drone. Flight operations. Flight execution requires following the predetermined flight path and ensuring drone operation. This includes, before takeoff, inspect the drone, sensors, batteries, and other equipment. Check all systems and update the drone's firmware and flight control software. Drone launch. Check wind conditions, choose a takeoff position, and watch for obstacles before launching. Flight monitoring. Follow the drone's position, altitude, and battery levels throughout flight. Monitor telemetry data and assure flight stability with flight control software or base station. Adapting to situations. If mission conditions change, alter the flight plan or parameters, adjusting the flying height, aborting the mission, or changing the flight direction to avoid obstructions are examples. Maintain situational awareness. Observe the surroundings. Monitor for threats or incursions, and comply with airspace regulations during the flight. After the drone survey, the data must be processed to obtain useful information. This usually entails these steps. Data transfer. Move drone data to a computer or other storage medium. To avoid data loss or corruption, send and backup data securely. Use photogrammetry software to produce orthomosaics, point clouds, or 3D models from acquired photos. Image stitching, georeferencing, and feature extraction are typical. Data processing from sensors. Use specialist software to process LiDAR or thermal sensor datasets from the survey. Point cloud processing, classification, and data fusion are examples. Validation and quality control. Check data quality to verify accuracy. This may involve checking outputs for mistakes, validating surveyed features, and comparing results to ground truth data or reference sources. Store and organize data. Structure processed data so it's easy to find and analyze. Effective metadata and tagging aid data retrieval and administration. Data analysis. Data can be evaluated after processing to get insights and make informed decisions. This may involve identify and extract desired features from processed data, measure distances, areas, volumes, or detect abnormalities or changes over time. Quantitative analysis. Assess data and extract useful information using statistical or modeling methods. Calculate vegetation indices, estimate crop yields, or find patterns or trends in the surveyed area. Comparative analysis. Compare surveyed data to past surveys or reference datasets to track changes, progress, or intervention or management effectiveness. Report and visualize analyzed data clearly. Maps, charts, and 3D models help present findings and conclusions. Use evaluated data and insights to help decision-making. This could involve resource allocation, intervention planning, or improvement or remediation. Drone surveying has transformed land surveys by collecting data faster and cheaper. Surveyors can now collect accurate and thorough data from many applications thanks to drone technology and sensors. Drone surveys can inform industry and sector decisions by following suitable planning, flight execution, and data processing protocols. For more insights into the latest surveying technologies and tips on choosing the best equipment, don't forget to hit the subscribe button and ring the notification bell. Subscribe now and elevate your surveying game.